China just built the world's largest undersea tunnel in 110 days. That's less than 4 months to bore through 57 feet of earth beneath one of the most unpredictable rivers on the planet. Most countries spend a decade on projects like this. China did it in the time it takes most people to finish a home renovation. And the machine they use to pull this off weighs more than a Boeing 747 and generates enough torque to power a small city. Here's how they shattered every rule of underground construction. The Yellow River isn't just water. It's 3,395 miles of sediment, unpredictability, and raw geological chaos. The Chinese call it the Mother River, but they also call it China's sorrow. It's flooded over 1,500 times in recorded history. It's killed millions. And in 2024, it stood between Jinan's 9 million people and the future of an entire economic region. On the south side of the river, you had Jinan's main urban core. Factories, offices, residential towers, the economic engine of Shandong province. On the north side, a brand new state-level strategic pilot zone for free trade, innovation, and economic reform. Billions of dollars in investment, thousands of jobs, an entire region's economic integration riding on one problem: how do you connect them? Bridges were already maxed out. Traffic crawled. Goods sat in trucks for hours. Every delay cost money. Every bottleneck strangled growth. The city needed a direct artery beneath the river. But here's the problem most people don't understand about the Yellow River. The geology beneath it is a nightmare. You're not drilling through solid rock. You're cutting through layers of clay, silty clay, sand, silt, calcareous nodules, and something called glued sand. It's inconsistent. It shifts. It clogs machinery. And at the depths they needed to go, you're dealing with water and soil pressure hitting 6.3 bars. That's 6.3 kilograms of force crushing down on every square centimeter. One mistake, one miscalculation, and the river comes pouring in. Traditional tunneling methods would take years, maybe a decade if you factored in geological surveys, environmental studies, and the sheer complexity of boring through that mess. Jinan didn't have years. The economic cost of waiting was too high. Every month without that connection meant lost investment, delayed projects, and a strategic pilot zone that couldn't reach its potential. They needed something that had never been done before. But to understand what they built, you first need to understand the monster they built it with. In May 2024, a machine arrived in Jinan that most people couldn't comprehend, even if they stood next to it. They called it Shanhei. In English, that means mountains and rivers. And when you see the specs, the name makes sense. 163 meters long. That's longer than 1.5 football fields. 5,200 metric tons. That's heavier than 4 fully loaded Airbus, a 380s. And the cutting diameter? 17.5 meters, 57.4 feet across. Stand it upright and you're looking at the height of a 5-story building. This wasn't just a tunnel boring machine. This was the largest diameter slurry balance shield machine ever put into operation. But here's what separates Shanhei from every other mega borer that came before it: the power. The cutter head driver generates 7,510 horsepower. To put that in perspective, a Formula One race car maxes out at around 1,000 horsepower. But horsepower isn't even the impressive part. It's the torque. 25,827,209 pound-feet of rotational force. That's enough torque to twist steel like paper, enough to chew through clay, silt, sand, and calcareous nodules that would jam a lesser machine in minutes. Manufactured by Connect in Germany, Shanhei represented the absolute bleeding edge of tunneling technology. But it wasn't just brute force. The engineering inside this machine is what made the impossible timeline possible. The cutter head is equipped with a specialized flushing system designed specifically for clayey soil. Because here's the problem with clay: it sticks, it clogs, it gums up cutting tools and brings boring operations to a grinding halt. Traditional machines would need constant hyperbaric interventions, sending workers into pressurized chambers to manually clear the blockages. Dangerous, time-consuming, expensive. Shanhei solved this with a telescopic camera system installed directly in the excavation chamber. Engineers could monitor the tunnel face in real time. They could see the condition of every cutting tool. They could watch how the geology was behaving. And they could make adjustments on the fly without ever sending a human into that pressurized hellscape. But the real breakthrough? The speed. Previous 17-meter class shield machines averaged maybe 10 meters a day if conditions were perfect. Shanhei was hitting 16 to 18 meters every single day. That's a world record for this diameter class. And it wasn't a fluke. It was consistent. Day after day, boring through some of the most challenging geology on Earth, Shanhe maintained that pace. On September 1st, 2024, they fired it up for the first time. The launch ceremony was brief. No grand speeches, no political theater. Just engineers, construction crews, and a 5,000-ton machine about to attempt something no one had ever done before. The clock started ticking. But hitting that speed meant nothing if they couldn't build the tunnel structure fast enough to keep up. Most underwater tunnels are simple tubes, one level, straightforward. But Jinan's engineers weren't building a simple tunnel. They were building something that had never been attempted at this scale. A double-deck road tunnel with 6 lanes of traffic stacked on top of each other. 3 lanes going north on the upper deck, 3 lanes going south on the lower deck. All of it inside a single tube with an external diameter of 16.8 meters and an internal diameter of 15.4 meters. The entire structure would span 5,755 meters, with 3,290 meters of that carved out by Shanhei beneath the Yellow River itself. But here's where the engineering gets brutal. You can't just bore a straight line under a river. The geology won't allow it. The pressure differentials will crush you. So they designed a V-shaped descent. The tunnel would drop from the southern entrance, reaching its lowest point at 1,820 meters, then angle back upward toward the northern exit, all while maintaining a grade that vehicles could safely navigate at 60 kilometers per hour. That means every single degree of that descent and ascent had to be calculated to the millimeter. Too steep, and you've got trucks burning out their brakes. Too shallow, and you're not deep enough to avoid the worst of the river's geological chaos. They threaded a needle through 57 feet of earth, with the margin for error measured in fractions of an inch. And then there's the segments themselves. As Shanhei bored forward, it wasn't just cutting through earth. It was simultaneously building the tunnel behind it. 500 prefabricated concrete pipe rings, each one engineered to exact specifications. Each ring had to lock perfectly with the one before it. Waterproof seals, structural integrity to withstand 6.3 bars of pressure, and every single segment had to be installed while Shanhei kept moving forward. Think about that for a second. You're installing a permanent concrete structure in a hole that's actively trying to collapse, while water and soil are pressing in from every direction. One gap in the seals, one misalignment, and the Yellow River finds its way in. Game over. The installation process was a ballet of precision machinery. As the cutter head chewed forward, hydraulic systems would position the next ring segment. Workers would lock it into place. Grout would be injected to fill any voids between the segments and the surrounding earth. And then Shanhei would push forward another 16 to 18 meters and do it all over again. No brakes, no downtime, no room for error. But precision engineering means nothing if the geology decides to fight back. September 1st, 2024. Shanhei's cutter head bit into the earth for the first time. 110 days later, they would complete what should have taken years. But between those 2 dates, everything that could go wrong did. The first week was perfect, almost too perfect. Shanhei chewed through the initial geology at 18 meters per day. The segment installation kept pace. The crews found their rhythm. Engineers monitoring the telescopic cameras saw clean cuts, minimal clogging, textbook conditions. Then the clay hit. Not just clay. Dense, sticky, wet clay mixed with calcareous nodules that turn the excavation chamber into a grinding, clogging mess. The kind of clay that stops machines dead. the kind that forces projects into months-long delays while crews figure out how to clear it. This was the geological nightmare they'd been warned about. Shanhei's cutter head slowed, not by much, but enough, 14 meters per day. Then 12. The flushing system was working overtime, blasting water to keep the clay from building up. The telescopic cameras showed material sticking to the cutting tools, forming hard layers that reduced efficiency with every rotation. But here's what separates a world record project from a failure. They didn't stop to fix it. They adapted in real time. The team installed jaw crushers directly into the slurry management system. They developed a dual-line pipeline hydraulic quarrying device that could handle the dense material without clogging. They modified the waste slurry treatment process with a concentration and filter press system that kept everything moving. And most importantly, they kept boring. By week 3, they were back to 16 meters per day. By week 5, they hit their stride, 18 meters daily, sometimes more. The innovation wasn't just in the machine. It was in the crew's ability to solve problems faster than the geology could create them. But speed created its own problems. The faster Shanhe bored, the faster they had to install segments. The faster they installed segments, the tighter the quality control window became. Every ring had to be perfect. Every seal had to hold. Because at the pace they were moving, there was no time to go back and fix mistakes. The Yellow River doesn't give you second chances. Round-the-clock operations. 3 shifts rotating every 8 hours. Engineers monitoring pressure readings, segment alignments, slurry density, cutter head temperatures. One senior engineer, Zhou Xiang, later said they held multiple scheduling meetings every single day just to keep the machine fed with segments and the crews coordinated. By late October, they'd crossed 1,000 meters. The V-shaped descent was working. The pressure calculations held. The segments were locking together perfectly. They were doing something no one had done before and making it look routine. Then came November, the best month in tunneling history. 426 meters in 30 days. That's a world record for any 17-meter diameter shield tunnel ever built. Not just in China, anywhere, ever. They were boring through the Yellow River faster than most projects bore through solid rock. December brought the final push. 2,000 meters crossed, then 2,500. The northern embankment was approaching, the most sensitive section of the entire project. One miscalculation here, and they could compromise the structural integrity of the river's flood defenses. The margin for error shrank to millimeters. December 19th, 2024, day 110. Shanhei's cutter head broke through the northern embankment. 2 miles of 57-foot diameter tunnel, 500 concrete segments locked together beneath one of the most dangerous rivers in human history. The underwater shielding section was complete. They didn't just break the record for largest diameter. They shattered the record for speed. What takes other countries years to plan and execute, China did in less time than a college semester. But the completion of the boring was just one milestone. Here's what they don't tell you about boring through clay at 17 meters per diameter. The bigger the machine, the more catastrophic the failure when things go wrong. Around week 7, Shanhei hit a layer of clay so dense, so sticky, that the flushing system couldn't keep up. The cutter head was still spinning, still cutting, but material was building up faster than it could be cleared. The telescopic cameras showed what every tunneling engineer dreads: a thick coating forming on the cutting tools, hardening with each rotation. In traditional projects, this is where you stop. You depressurize. You send crews into hyperbaric chambers for intervention. You manually chip away the buildup. It takes days, sometimes weeks. And every day you're stopped, you're bleeding money and falling behind schedule. But stopping wasn't an option. Not on this timeline. The pressure in the excavation chamber was already at 6.3 bars. That's 91 pounds per square inch, crushing in from every direction. Sending humans into that environment meant specialized equipment, medical monitoring, decompression protocols. It meant risk, and it meant time they didn't have. So they did something that had never been tested at this scale. They reverse engineered the problem while Shanhei was still boring. Engineers designed a jaw crusher system that could be integrated into the slurry line without stopping operations. The crusher would break down the dense clay and nodules before they could harden in the pipes. But installing it meant modifying the hydraulic quarrying device while material was actively flowing through it. Think about that. You're performing surgery on a system that's processing tons of material per minute, under pressure, with zero margin for error. One mistake, and you've got a blockage that could take weeks to clear. They pulled it off in 36 hours. The dual-line pipeline system went live. One line could keep operating while they serviced the other. The jaw crushers reduced the calcareous nodules to manageable sizes. The modified filter press system handled the increased slurry density, and Shanhei never stopped moving. But the clay wasn't the only enemy. Around meter 1,200, they hit a pocket of water-saturated silt, the kind that turns into liquid the moment you disturb it. The pressure reading spiked. The tunnel face became unstable. If the slurry balance was even slightly off, the face could collapse, sending tons of liquefied earth flooding into the excavation chamber. The telescopic camera became their lifeline. Engineers watched the face in real time, adjusting the slurry pressure on the fly. Too much pressure, and they'd blow out the face, compromising the riverbed above. Too little, and the face collapses inward. They were threading a needle with thousands of tons of earth trying to crush them from every angle. For 3 days, they crawled forward at 8 meters per day. Every meter a calculated risk, every adjustment a gamble. The crews worked in complete silence, watching monitors, adjusting valves, waiting for any sign that the face was stabilizing. On day 4, they broke through to more stable geology. The silt pocket was behind them. Shanhei accelerated back to 16 meters per day. But here's what makes this even more insane. While they were fighting geology underground, they were fighting regulations above ground. Environmental compliance didn't pause just because they were on a record-breaking timeline. Every cubic meter of waste slurry had to be treated before disposal. Every drop of water had to meet discharge standards. They built a complete waste treatment facility adjacent to the construction site. Slurry came up from Shanhei, went through separation, concentration, and filtration. Solid waste was collected. Water was treated and tested, all of it happening in real time while the machine bored forward. One environmental inspector later said it was the cleanest high-speed tunneling operation he'd ever witnessed. They were breaking records and breaking conventions. Speed didn't mean cutting corners. It meant engineering solutions that made speed possible without compromise. By meter 2000, the crews had encountered and solved 17 separate geological challenges. Each one could have derailed the project. Each one was overcome without stopping the machine. But the biggest challenge was still ahead. At meter 2,800, Shanhei approached the one section where failure wasn't just expensive, it was catastrophic. The southern embankment of the Yellow River, 49.2 meters of earth overhead. The river's primary flood defense. The barrier between 9 million people and one of history's deadliest waterways. And Shanhei had to bore directly beneath it without disturbing a single centimeter of its structural integrity. Here's the problem. Embankments settle. They compress under their own weight. They shift with seasonal water levels. They're not static structures. They're living, breathing masses of compacted earth that have been carefully engineered over decades to hold back millions of gallons of water. Disturb that balance, and you don't just get a leak. You get a collapse, a breach, a flood event that could devastate everything downstream. The engineers knew the margins before they started. Any ground settlement exceeding 5 millimeters would trigger emergency protocols. Any pressure variance beyond 0.2 bars could indicate structural compromise. They had installed hundreds of monitoring sensors throughout the embankment, real-time data feeding into control rooms. Every millimeter of movement tracked, every pressure fluctuation analyzed. Shanhei's approach had to be perfect. They slowed the boring speed to 12 meters per day. Not because the machine couldn't go faster, but because faster meant more vibration, more ground disturbance, more risk. The cutter head pressure was adjusted every 3 meters based on geological readings. The slurry balance was recalculated continuously. One mistake here and the Yellow River finds its way in. But here's what kept engineers awake at night. They couldn't see what was happening above them. Not directly, They were relying on sensors, calculations, and faith that their models were accurate. The telescopic camera showed them the tunnel face. The monitoring system showed them pressure and settlement data. But the embankment itself? That was 57 feet of earth they were cutting through blind. Meter, 2,850. The sensors showed 0.8 millimeters of settlement, within tolerance, but rising. The team adjusted the slurry pressure, increasing support to the tunnel face. The settlement stabilized. Meter 2,900. Settlement hit 1.4 millimeters. Still safe, but the rate of change was increasing. They slowed to 10 meters per day, adjusted the excavation sequence. Increased the grout injection behind the segments to provide immediate ground support. Then the pressure readings spiked. Not a huge spike, 0.3 bars, but it was unexpected. The geological model hadn't predicted a pressure variance at this location. Something in the embankment structure was different from the surveys. Maybe a lens of clay they'd missed. Maybe a void that had developed over time. Whatever it was pushing back. The decision point: stop and investigate, or trust the machine and keep moving? Stopping meant depressurizing. Investigating meant drilling relief holes from the surface. Time meant days, maybe weeks. And every day stopped meant the project timeline was blown. The 110-day sprint would become just another construction project that ran over schedule. Zhou Shang made the call. They kept boring, but they added 3 additional monitoring points and dropped the advance rate to 8 meters per day. If the pressure spiked again, they'd stop. But until then, they'd trust the engineering. Meter 2,950. The pressure normalized. Whatever they'd encountered, Shanhei had cut through it. The settlement readings held steady at 2.1 millimeters. The embankment was stable. By meter 3,000, they were through the most dangerous section. The embankment sensors showed total settlement of 3.7 millimeters, well within the 5 millimeter tolerance. The Yellow River's flood defenses remained intact. The gamble had paid off. But now, they faced the final test, the northern embankment breakthrough, the moment where Shanhei would cut through to open air and any miscalculation would be immediately catastrophically visible. December 19th, 2024, day 110. Shanhe's cutter head was 3 meters from breakthrough. The entire project came down to this moment: 3,290 meters of tunnel behind them, 57 feet of precision boring through impossible geology, 500 concrete segments locked together beneath the Yellow River, and now, 3 final meters. They slowed to 1 meter per hour. The telescopic cameras showed the northern embankment material changing. Lighter soil, less pressure. The tunnel face was thinning. Every rotation of the cutter head brought them closer to daylight. At 2:15 p.m., the breakthrough alarm sounded. Shanhe's cutting tools broke through the northern embankment. Sunlight poured into the excavation chamber for the first time in 110 days. The crew erupted. Engineers who hadn't slept more than 4 hours a night for months just stared at the monitors. They'd actually done it. The world's largest diameter underwater shield tunnel, completed in less time than it takes most countries to finish the planning phase. 57.4 feet of precision, 2 miles of impossible engineering, under one of the most dangerous rivers in human history. Other countries measure mega projects in years. China measured this one in days.